All right, what is up, everyone? Week 97, building my own operating system. Thank you for joining. I'm coming back after a couple weeks of doing pre-recorded streams because I was away on a trip. So I literally did not even have a single free moment. So I'm going to be picking up directly where I left off with last time, which was, I think, in the middle of like some virtual memory stuff. I almost don't remember. Let me open up my text editor. I think we were working on like this VirtAddr class or something like this, but just give me a moment to get set up. Yeah, so I think, in general, we're working on virtual memory support. And one thing that I'm particularly interested to explore is seeing if I can make any of this unit testable, because I think unit tests are good. I think they can help catch bugs. I don't know of that many other operating systems that do unit tests, to be honest, although I'll be very curious to see some. And I've spent some time investing into some unit test infrastructure, and it seems to kind of work okay. It does add some complications to the code, though. Dapster, what is up? Yeah, I was going to reply to you in Discord after the stream. Yeah, nice to see you, though. Thanks for joining. You're wondering, what is the... First started in C. If you could start again using C++, what would I do differently? What resources? So when I first started the project, I wasn't building my own OS from scratch. I was doing all of this freely available online coursework. And the coursework had this skeleton OS that was in C. And so, yes, I was using C at that point. And that was for like the first year of doing this about. And then I kind of switched over to my own operating system, which I've been doing in C++. So that's in fact what I basically have been starting over mostly from scratch in C++. And I'm doing everything differently. I'm doing like so much differently. I mean, there are some similarities to the previous OS, and actually I think the OS that I'm working on now, this newer one, maybe some of the design will be similar, but in terms of the implementation, in terms of the project structuring, in terms of the build system, in terms of the architecture of the code between unit tests and the production kernel, I'm doing all of that very differently. So yes. Afnan, what is up? Good to see you again. It's been a bit. Hope you're doing well. Hell yeah, we got May. How do you say your name? Mayos? Stand on Chicken. Thank you for the test too. Got some good. We got a nice chain of test comments in the chat. Thank you. Yeah. So yeah, Dapster. I think. I mean, so those are just some examples. And I honestly, in terms of resources, I have not really been using a lot of resources. I think the main resource just has been that coursework I followed, that MIT course, for that whole year. And since then, I've been just sort of doing it on my own. I'm busy with startup. Often I'm working at the startup. That's pretty cool. Yeah, no problem. Feel free to share some more about that startup life if you want. Like, what kind of work are you doing? What industry is it in? I'm just gonna demo something kind of quick. I have been playing around with something that I hope will be kind of cool. So I got an iPad recently, and I think what this allows me to do is draw on the stream. I wasn't really able to do this before, but yeah, now you can like kind of follow my drawings a little bit. I was doing this a little bit on the other streams, so I'm hoping this will be a little bit more engaging. And even just better for me, just to be able to draw things out. Let's go. Lizard in the house. What's up, Lizard? Nice to see you. Hope you're doing well. Okay, so yeah, like I'm coming back really just kind of raw into this today. Have not really prepared very much. I don't know if it's helpful to quickly look at the Git history, although it's kind of a huge mess because I haven't had a chance to do any kind of cleanup. But as a general trend, over the last maybe month or so in the streams, we have been working on virtual memory and page tables. Drop the config of this demo. Well, what do you wait? What you mean the lazy Git config, or what demo are you talking about? Because I don't really use a lazy. I use like almost nothing. There's like almost no configurations. Okay. But yeah, so Dapster asking what prerequisites for OS dev. Oh, the iPad. So Dapster, I mean, I would say the prerequisite is you should be pretty strong in at least C, probably. Yeah, you should be quite comfortable with structures and pointers, understanding what memory allocation is. I think that's important. Other than that, I think that's sort of a bare minimum, and then you can take an OS class. And that's what I would recommend. I would not recommend going on the OS Dev Wiki and just going like raw with just like trying to figure it out. I mean, you can use some templates, but yeah, I don't know. I think yeah, ARMv8 assembly. Since I'm on a Mac also, but I'm doing x86 because I don't really know ARMv8 that well. So just because you're on a Mac doesn't mean you need to develop like a Mac OS. Like you're not running it on hardware probably. So yeah. Wizard with the ARPites 2350 board. Oh, that's sick. Wait, RP 2350 is that microcontroller if I'm recalling it correctly? And you said you have a board. So it's like a dev board with the microcontroller on it? Or something like this, and maybe the dev board exposes some peripherals or something like that. That sounds pretty cool. Yeah, okay, that's sick. Yeah, I've always kind of been curious about those microcontrollers. I've never used them before. I've only ever played with like the embedded Linux things. Okay, maybe I'll get into the code. Get into some of the code now. So this is like all garbage. I added this class for the FizzMap adder converter, which is pretty simple. It's just the code that converts between physical and virtual addresses for addresses within the linear mapping of physical memory, also called the FizzMap. And I worked on some tests for that. I added some assertions. And then this is kind of where we left off last time. I was sort of working on this VirtAddr class, because the idea is sort of to work on this VAddressSpace class and start mapping some page tables and stuff like this. But I just noticed that when we work on this virtual memory and page table stuff and like all of that stuff, we're just going to be doing a lot of working with these pointers. So like this is going to be our life for this code. This diagram right here and all these numbers. We're going to need to be extracting indices and like all sorts of stuff. And it might be nice to just have an abstraction that makes this easy to do. So I think so that was the idea. And then that's sort of what I started working on last time, is this VAddressSpace class. And I guess that's what I will probably just continue with today. And let me start from scratch. So memory types, I think was the name of this thing. Test memory types. So we have, right, so we have this class, and we have our unit tests. And let's just give things a quick run just to quick check on the make file. Are we using -j at all? Yes. No. Maybe. Reset host. Maybe not. Wait, what? I just wanted to check if I actually don't think parallelism is being used in the build right now, which is like this builds the target stuff and the host stuff in parallel, but in terms of the specific build internally, I think it actually does not use the parallelism, which I don't love. I'm gonna do this, I think. It's a little bit of a guess. I'm just gonna ask the AI maybe. Also, I'm curious if I can use, I'm using this whisper flow thing to talk to my computer. And I don't know. Is this the right way to add parallelism to my builds here? Oh. Okay, I'm gonna undo that. Okay, whatever. That was a bit of a distraction. So we're building, and what is going on? Why are all the tests failing? What? What? Okay, this is super weird. No exception was thrown. And also this thing just straight up crashed. empty. What is going on? Okay, so it looks like we'll be figuring this out. Okay, before I dive like too deep, what did I even do? This is like a random commit that tries to enable being able to use the O1 optimization level, which was like a bit random. Let's make a backup branch. Okay, what if I just don't use that commit? Yeah, no way. That, I don't even know how that is possible, but this commit, what? Oh, wait, that's why. I disabled assertions for some reason. Okay, that's stupid. Okay, back to the real stuff. So yeah, okay, I'm gonna, maybe I'll rename this branch with opt patch. Okay, back to here. Okay, so sorry, I'm a bit confused. This fails. Okay. I'm just going to drop this whole commit. We don't need this. Okay. Okay. Things are passing. Okay. What's up, Jayesh? I'm using C++. So now we're okay. Now we're in a clean slate, able to get going. Yeah. So moving back along, moving back here. You know, and I think I was actually reflecting. I think I wanted to do this a bit differently. Also, let me get my break timer. That's set up. I mean, it's been about 20 minutes. Let's just go ahead and take the 20-second. Okay, so yes. Creating an OS prescribed GPU, new NPC, or can I create my own laptop? You don't need a GPU. I mean, you don't, no, you can create an OS on a very old laptop. You just need QEMU. Anything that runs Linux should be fine. If it's on a laptop, I just get the QEMU emulator, get some cross compilers, and you're good. No GPU needed. Okay, let's sketch this out. I'm going to, I don't know the name for this, but I have an idea about how I want to do this instead. So, set table. This might be a bad idea, but, and rather than having this whole thing, depth. we're just gonna take a depth, and then we'll just switch on all of these things. Okay, and that's not really what I want, but to start, so just for example, so for example, maybe I'll, that's a little bit verbose. What's up, Faikwa, or Faik Abdullah? I mean, own OS. I mean, the way I learned was by doing the MIT content, basically. And so I guess it depends on what exactly is overwhelming to you. But in general, I recommend people just to do an OS course, which it sounds like you're kind of doing. Why doesn't people start in 64-bit mode? Why deal with 16-bit? That's because of compatibility. And so Intel doesn't assume that you're running some new software. It leaves compatibility open in case you're running some ancient 16-bit application. Okay. But wait, okay. I'm just gonna kind of lock in a little bit over here. So what I'm trying to do, right. So I'm kind of replicating what I have over here. So if we want the offset, we're gonna do and bit mask 12. If we want the page, so page, right, all this is going to go away. And you know, this is a bit chunky. I'll just leave it for now. Okay, page, right. Yeah, if it's overwhelming, I would say just don't, just start with a little bit. Like when dealing with a large code base, just find a little corner of it that you can kind of use as a starting point to understand, and then just branch out from there. Like just start with, I don't know, like the core structures or something like this, like the task structures or something like that. That's what I would recommend. I think I'd never finished this actually. So wait, okay, so let me move a bit more slowly, but let's starting off here. So okay, what is the problem there actually? Seems like it's failing to compile. Missing switch. Okay, so it's gonna it's asking me to assert. Right, I'm just gonna assert on those for the moment. I don't even have assert here. Just call it, okay. There we go. Okay. Okay, so that's cool. Yep. Like this. Okay, just to get kind of going. Okay, so let's just run the tests again. They all pass, good. Okay, so now just trying to do some other tests. This is a little bit annoying to do and maybe kind of error prone. I might ask the AI to help me or not, I don't know. Page table fraud, I see. I guess so, not sure what that means. Okay. So let's say I wanted to Dapster when I find a tutorial and advice as someone who takes trouble taking an abstract. I mean, there are a lot of OS tutorials, but I mean, Dapster, like I kind of said before, an OS course where they like walk you through it is like worked very well for me. It's not just a book, like they actually give you exercises and stuff. And it's basically a tutorial, but like way better, so. Okay, Mo, that's kind of it. I don't even know what those are, those low level registers. Sorry. So I'm working with 4 level page tables, I believe they're called. 4 level paging, yep. So I'm just trying to think about what the test here is going to be, and I basically just want to craft like, what is like an interesting kind of number or way to test this. This is kind of the least interesting part of this whole thing. But yeah, so I'm going to kind of try to test-driven develop. You know what, I'm just going to ask the AI. I'm just going to, okay. I'm trying to write some unit tests for my virtual address class, and I'd like you to help me generate a virtual address number such that each portion of the virtual address which indexes into the different page tables has a different value, and then check those in the unit test. I don't think that was kind of a bad prompt. I didn't really know to say, but let's just see what it can do for me in that regard. Basically what I just want to generate like a number that where there's something distinct here, 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 here. And then I can just code my unit tests and just test that they're extracting the number correctly. Okay, let's code review this real quick. Subcentrified. I'll link you to the course that I followed. I don't have a name for my OS yet. Oh, page table base register? Page table length register? Okay, so in x86, the CR3 is the page table base register, but there's no length. There's just each page table is 4K. Okay, let's code review this real quick. So 0 to 11, 12 to 20, 21 to 29, 30 to 38, 39 to 47. That looks pretty good to me. Right, okay. Yeah, okay. Okay, this is looking kind of okay. Just work it out. These are 9. So wait, what's up? Okay, so it's also not public centrified. It's just my own private OS. Well, wait a sec. Is this right? Because this is 8 bits. So we're using 8 of the 9 bits. Okay. And so in the test, we're going to confirm that we're just asking for different things, and we should get the things that we expect. I'm going to keep this suggestion. And then now we can do RTDD, and the tests fail. Obviously these are going to fail because we haven't implemented them yet. And then let me see. Right, so this is failing also because it's wrong, apparently. The PML4 is just the top, the top page table. There's just a single one of those. So is this correct? This thing on the bottom, shift it over 12. 3C, shift it over 21. That thing shifted over 30. This thing over 39, right? And so what am I doing wrong? So I was taking this and I was shifting it over 12 bits and then trying to mask that by 9 bits. All right, what is... I'm giving 109. Okay. I'm just gonna stupidly log a few things out. First of all, I'm just gonna just curious, does this work? So does this match D? All right, be right back. Okay, it's been a while since I've really embarrassed myself badly on stream, so I think this will be kind of due for another one of those streams. So D5, okay, so that number is right. And so obviously now the question is this. So I probably just have a really stupid. Okay, and then, so obviously that's I didn't need to do this. That's easy because we're like nibble aligned so far. And so it's just 4D 5EF. And what am I getting out of here? 6. Oh wait, what? Okay, yeah, so right. This has got to be so stupid. Wait, did it do, okay, did it do the math wrong? You know, I'm trying my best to be an AI. What? Oh my gosh. Oh, that's why it didn't work. The AI did the math wrong. I'm here being like, how did I possibly mess this up? And the reason is it literally just did the math. This is the number that should be here. Oh my gosh. That is kind of infuriating. So that's interesting. Oh, what's it? Empathy Monster. I'm using tmux with LazyGit and fish shell. That's how I'm working these days. Okay, that was crazy. Okay, I really want to be optimistic about AI, but that moment was not great. Okay, so moving on. Because you could just tell, like, what? Why is there a 4D here and then a 6D over here? Sheesh. Okay, let's run that back and try it one more time. Tests pass. Lord, okay. Okay. I thought I was going absolutely crazy. Okay, let's move on. PageAddr, right? Gonna be a similar thing, except, and how much are we shifting? This is like not that hard. We just shift whatever this number is, 21. Bitmask 9. Let's run it up. That's passing. Just to be safe, let's make sure the test fails if I did it wrong. Let's say I did 8 here. Let's just see the test fail. Test did not fail. And the test didn't fail because there weren't enough bits. The thing is, this number is very lenient. I like it to, yeah, the reason, because it's a 4 here, but there's zeros in the high bits, meaning if we don't mask enough, it doesn't actually cause a problem because those bits are 0 anyway. So the number I need at least, I want to have at least a high bit there. And so what I'm going to do is I'm tempted to ask the AI again, but I'm just going to, I think, what is it? 13, no, 9, right. I'm going to use a 9 for these, for like all of these, I think. And that will help me catch these kinds of errors where I don't mask it correctly. And I'm going to go and copy and paste this. I mean, you know what? I could just directly use this as the, like, why am I auto num, right? This would work, right? Narrowing conversion, blah, blah, blah. 64. Let's try that again. So now everything is failing except for hopefully the first one. What? With logging here. What? Dude, what number is that? Okay, clearly. Okay, check it out. This is a 32-bit. Wait, no, wait, what? This is larger than 30. So clearly clearly that did not work. Okay, let me just do it this actual stupid way. Okay, that's the number we should have. Tests should. Now that's more like it. Holy crap. I'm trying to make this 9, trying to make this also 9. And now, like, the test should still fail, right? I've injected the bug, which is the 8. And previously, the test was not catching this bug because I wasn't using enough bits in this part. And so now I'm using... What? Why did the test fit? What? Holy crap. Okay. What's up, chillin' moments? Hello, bro. This is from scratch. Yeah, it's not based on Linux. Oh my gosh. This is driving me insane. 9D, 9C. Oh, but wait, but the thing is, that's sort of what I'm saying. These are 9 bits numbers, and so even these choice of I need a 9-bit number here. So actually, I don't. So here it's 12 bits. Everything here is 9. It's 9, 9. 9 and 9. Everything else is 9. Okay, so I need these to all be 9-bit numbers. So congratulations, now I've officially created my 9-bit number. And yeah, so now I can kind of go back to that system they were doing before of like the 1, 2, 3. I mean, it doesn't really matter. I don't even know. Maybe I'll just make it 0 actually. Oh dang. How do I do this in Vim? Is it capital R? No, that like C0? There we go. My goal is just to have a unique number with a 1 in the high bit. I'm just trying to fill in all these slots, right? And so I just want a unique number to be in here with a 1 on the high bit so I can test the boundary well. And now I guess I will kind of stupidly just go in here and fix up my numbers. This is a little bit painful. Thanks for bearing with me. But now, and also like what's up with this? I think, why is it 5EF? Let's just make it ABC or something. Let's see. So now we go here, we officially get the number, and I'm kind of doing my stupid way of pasting it into my terminal. Copy and paste this. Now these things change. So now we're testing for ABC. We're testing for 10D. Testing for 10C. Now here is the part, hopefully, where this should finally fail on us. So let's just run it one more time. There we go. The PageDir test, the 10C test is failing because we injected the bug. Now let's correct the bug. And we can hopefully see the tests pass. That's great. Oh, okay, well, I was like, why is the test running twice? It's because my MUT thing automatically runs the tests. I forgot about that. Okay. Okay, that's a little bit nicer. Dang, we got 27 people in the chat right now? What? Dang, appreciate you all being in the chat right now. It's a lot more than I've been usually getting, so appreciate that. Okay, so that's just me. What's the name of the OS? There is no name for the moment. Hey, Alaviem, or however you pronounce your name. Really nice to see you. Thanks for joining. Appreciate that. Yeah, it's been nice chatting with you over the last couple of days. Appreciate that. And I really enjoyed reading your OS. You know, for everyone in the chat right now, you need to go check out this OS by Alaviem. Let me just bring that up real quick. This is some cool stuff. I'm just looking through the Discord. How do I even find the link to this? Scroll. Okay, let's go. Copy the link. For everyone in the chat, if you're interested in OS development, check out this operating system. Written by none other than Alaviem. Solera OS kernel. This is legit. This is my dream. One day, maybe I can get here. But yeah, let's pop that in the chat. Could you give a percent that the project is that? What would you say it is? Man, I don't think in terms of percents. I don't think in terms of end completion. I think I'll just say we're really at the early stages. Like, bro, I'm literally making a virtual address class right now. Like, we are beginning from the very raw beginnings. So we got a lot more work to do. I would call it 1%. I don't know. No, correct way to pronounce the name. Yeah, no worries. Spice Monkey, I mean, I'll just recommend you to what I've been doing. I followed this course for a long time before I started my own OS. and it worked pretty well for me. But I've also heard some feedback that this course that I'm linking, oh, maybe my bot's broken. Is my bot broken? Let me, here we go. Sorry, here we go. Okay, so here's what I did. And I've heard some feedback that this course has some downsides, like it's very bit rotten, and that's super true. And some context on the week 93. So the first year of me doing streaming was working on this course OS. And then about 9 months ago, I restarted working on my own custom OS in C++. And so the 93 weeks has not been me from day one on my own OS. I've been working on it since a bit earlier this year, call it like maybe May or so. Also, I only work on this for 2 hours a week, guys. And so if you have more time than me, you can make a lot more progress than I can make. But yeah. But no, like what I've kind of found is that this is just a nice place to work, and it's my own project. I can just, and there's a lot of work to do, and I enjoy it, and I can just kind of be here for a long, over a long span of time, just keep working on it. So appreciate that, Maz Munir. This is it's just a fun project for me. It is just a fun project for me to learn and have fun and just, yeah. And it's not a Linux distro. This is so not a Linux distro. It's a custom OS in C++. Week. Oh shit! Wait. Oh, I think the week numbers are going down. Wait. I think I forgot to update the YouTube title today. That's why. Today is week 97. I forgot to update the YouTube today. Yeah. Last week was week 96. It is an error that today it says 93. Today is 97. So thanks for pointing that out. The week numbers are going down. Now that would be some kind of crazy thing. I'm not counting down the weeks. No. Yeah. Spice Mike, what's the setup or development strategy? I mean, the setup briefly. I'm using C++. I'm using Lemony bootloader, 64-bit x86. I'm using a ton of third-party libraries because I enjoy doing that. I'm using Frig, which is the C++ thing from the Managarm project. I'm using freestanding C and C++ headers from the author of Lemony bootloader. I'm using embedded template library, which I have not used yet in the production kernel, but I have it available in the build in case I want to. And that is kind of it so far. So, yeah. All right, scared C++, I'd rather win Rust. Yeah, that's probably a fair take. I have a lot of experience with C++. That's the only reason I'm making this choice. If I did not have experience with C++, I would probably do it in Rust and learn Rust. All right, feel free to join me for a 20-second stand up and stretch or get some water or whatever. Okay, so now that we finally got like some stuff going, let's just finish up these tests. So we're going to page the PDPT table or whatever this thing is. 35 people in the chat. What's going on with the internet today? Chat is popping off. All right. Let's just fill this out. And so back to over here. So to get this thing, we need to shift it down 30 bits and do the mask of the 9. All right. And then let's just run the test and make sure it passes. And then let's break the test or break the production code, for example, you know, just to see test fails. That's good. And then lastly, we can just finish this off by shifting it 39 bits. 39 bits, also getting, and to finish it off, we're looking for our 1LA. And let's just see this pass. Let's just see it fail. Never trust a test you have not seen fail. Cool. And now that sort of does it. And we can take a moment to reflect on this. And so I mean, I'm still kind of curious why this didn't work. It's probably a very basic thing. Is it really 39 bits? Yeah. So I'm trying to construct a Uint64T just out of these raw components. And if I do that, it does not work. And that's because something is obviously just going wrong with crafting that 64-bit integer. And I am wondering why that is, and I'm just gonna ask the AI. Unless someone in the chat can help me with this. Why doesn't constructing the 64-bit int like this in C++ code match this number? Like the stupid way I've been doing it is copy and pasting this out into my Python interpreter. But you know, we have C++ here, so we should be able to just calculate the number here, and it is a sign extension problem. I'm missing these ULL things everywhere, jeez. And yeah, Alluvium, I think you got it right. These things are like, they're assigned ints, assigned 32-bit int, and when you shift it beyond 32 bits, it causes undefined behavior. Yeah, interesting. So, yeah. Yeah, okay. This looks so weird to me, to be honest, though. I kind of hate how this looks. So I don't necessarily know. At the same time, I don't love the whole copy and pasting into a Python interpreter workflow. That really sucks also. And so I think between the two, I'm gonna go with this, even though it's kind of very strange looking to me. Like, it literally spells words, bull and dull, in my numbers. I'm just curious, can I, well, first of all, I don't love the capital letters. And can that be lowercase? I mean, that still looks so weird. Maybe I'll leave it as uppercase, but No worries. So Alavim, you suggested using the Uint64T. And that, no, sorry, yeah, that would look like this. And to be honest, dang, I hate typing out this whole long thing. Yeah, I'm just gonna have the AI do that for me. Let me just replace the ULL with uint64t. Can it do that? Yeah, I kind of like that a little bit better. Yeah, I mean, let's just go with that, I think. Let's just go with that. So, I mean, that's the basic test right there. We have these comments. I don't know if I love the comments. They can kind of get out of date. I might just delete all of this. Okay. So that's looking pretty good. So I just feel a little bit more comfortable about that now that I have some tests for this class. And I'm doing it in sort of this way where I use an enum because I don't know, I think I think it might come in handy to do it this way. Another alternative, using a macro or concept to guarantee that the bit shift applies as if the input is even though you don't say a macro context for inline. To guarantee that the bit shift applies as if the input is uint64t. You mean instead of doing it this way? Interesting. Yeah. I mean, I don't really hate how it looks right now. I think it's okay. Maybe what would be kind of nice is actually just breaking it into variables, actually. So like, like make a variable to hold each of these things rather than doing it all inline in this expression. That's just a little bit cleaner. Please break this into separate variables that get ORed together. Let's just see how the AI does it. In general, I try to avoid macros. I think I've heard that's good practice. So, yeah, okay. Let's just run it. And that seems to be working. Okay, cool, let's keep it. So what are we thinking about this? Can we use, can we make these auto? Please do that. I don't know. I would just do it myself, but I'm pretty sure you can. Right? I'm trying to use auto if I can. Okay, so we got some numbers. PML4, page offset. They all get ORed together. And I think I'm pretty happy with this. I think that's looking pretty okay to me. No need to really overdo it here. I mean, this is not really the most important. I mean, this is like kind of an important class, but it's not so worth spending an insane amount of time on it. So one more time with the runs, and then we can kind of do a commit. Except, wait a second, so I don't, okay, so we don't need the logging though. This hunk, like we're not logging anymore. This was just for debugging, so I'm gonna drop this. And then kind of likewise over here. I mean, this is all gonna kind of get squashed, I think. We also don't need the logging. So I'm only staging what I want to commit. And so I think I'm going to, I mean, all of this will need to get cleaned up later in the end. So I'm just going to whip add implement VirtAddr with tests. And now I can just drop these two hunks. Okay, cool. All right, I'm just gonna take a breath for a quick second. 1 second. So, what else? So now that we have our cool VirtAddr class, we can kind of get back to the main interesting thing we were trying to do, which is the VAddressSpace. And now instead of a p-dest-adder, we can take a const VirtAddr. Okay. And then okay, what is going on here? Why? Yeah, I was missing an include somehow. But what's up with that? Did I rename this thing? Fizzmap? Or is it just another clang? Or is it just another weird bug in like the IntelliSense? I think it was actually. Although it is true I was missing the include. So, why is it still complaining? Okay, let's just, sort of not cool. Okay, so kernel is building, even though this thing is complaining. It's a false positive. So now the idea is to start implementing these virtual address space types of functions, stuff like that. What's up, Android AOSP? I got Android AOSP in the chat. What's up? Using your own fork of a compiler to compile the components to be compatible with missing features such as exception handling. No, I'm not using my own fork of a compiler. I'm using the standard clang that comes with Homebrew on macOS. It's like a totally normal clang. And I'm just using compiler flags to disable the things I'm not using, like exceptions. And that's pretty much it. FAT or inode file system. I have not gotten there yet. Yeah, no file system yet. I'm kind of deferring all of that for the future. Yeah, one of my goals with this project is to not have a lot of complicated toolchain setup. Like the OS Dev Wiki tells you to like build your own toolchain, and maybe there's reasons why you might want to do that, but I'm not doing that, and it works pretty well for me. I think the only thing though is I need to manually invoke the linker. I'm not able to use the compiler as this whole driver that invokes the linker for me. I think that might be where you can run into problems with using like random tool chains. So I am just using this standard tool chain, but I'm running the linker manually. Otherwise it's pretty good. Like, yeah, no fancy complicated tool chain. Okay, so now here's a kind of an interesting part. I'm just curious what it would look like to unit test this. In general, I'm just interested in exploring what it's like to have a unit tested kernel. A lot of people don't do it, and I can see why. It's kind of annoying, not only to write the tests, but you need to architect your code in a specific way. And I've been able to write unit tests for a couple of these more trivial components, like my math function and like the bitmap allocator, which is pretty much just a raw data structure, so that's actually fairly easy. Like my VirtAddr, like my FizzMap adder converter, like these are all fairly straightforward to write unit tests for. But the VAddressSpace is a kind of a different beast. It's much more complicated because, for one thing, it needs to allocate memory. Okay, LVM chiming in. Reasons for your own toolchain: porting your OS, running GC on your OS, ABI mismatch, consistency, libc weirdness. Interesting. Yeah. Okay. Maybe there's things I don't know about. Yeah, I have not run into anything like this. I mean, ABI mismatch. Like, I'm not using any pre-compiled objects. I'm not using, and I mean, like, I'm just building everything all in tree, like all together. But a lot of it's header only anyway, so. Yeah, but maybe I'll run into it later. Yeah, I'll watch out for it in case I do. Okay, so here's the idea. Let's say we wanted to have a unit tested VAddressSpace. We haven't written it yet, but VAddressSpace is going to need to do a few things. It's going to need to allocate memory for the page tables, because this is going to allocate page tables. Like when we go to map a virtual address, it's going to need to potentially map, allocate memory for new page tables in the tree. And it also needs to do like physical address to virtual address conversion. So when we fill in the page table entries, those need to be physical addresses. But in order to fill in the page tables and actually work with them, those need to be virtual addresses so the kernel can work with them. And that's why it's taking the FizzMap adder converter to just sort of make it clear that this is going to need these two things, the bitmap frame allocator and the converter. The problem is when like I'm trying to extract this and run it in a unit test, which is not running in the kernel. It's going to run on my dev machine, and memory allocation and even this conversion is going to be kind of different in that world. In this unit test world, this memory allocator is just sort of like a normal memory allocator. It might literally call malloc or something like this because we have malloc. And likewise, the FizzMap adder converter is going to basically be a no-op. In the unit test world, everything's in user space. There's just no physical addresses at all. And so there's no conversion. And so there needs to be kind of like a no-op FizzMap adder converter. So these are a couple practical challenges with trying to run this in user space. Also, what's the pacvan one? Nice to see you again. And it's totally possible it's not worth the effort, but I'm still curious to try it. And so I'm just trying to think about how to move forward. And my idea is, so I think I need to make both of these actually interfaces where we can have different implementations kind of provided to it. And so in the kernel, it's going to take the actual kernel's real FizzMap adder converter and the real bitmap frame allocator. But when running in the unit test, I'm going to provide different implementations of these. I'm going to provide a bitmap frame allocator that uses malloc under the hood. And let's just check out the API. Like, what's the API? alloc and free and num free frames. All right, quick 20 seconds, be right back. Okay, Baki asks, if I made a bootloader, where would I start? So first off, I don't really know. I have not really worked on a bootloader. I mean, you could start with writing like a legacy BIOS 16-bit bootloader, which people sometimes, I mean, that's kind of popular in the space for some reason, actually. People write these, it's like that whole BIOS 512 bytes of 16-bit mode assembly sort of thing. But I don't know, like that's painful for a lot of reasons, and also completely legacy technology. Straight up, I've never written a bootloader really. You could do it with UEFI potentially. That might be a better question for a bootloader Discord or something, or maybe the Limini bootloader Discord. So this is the API we would need to, so let's just give it a try. I don't really know. Let's just give it a try. So basically we need to extract an interface. So, and I think I'm gonna rely on AI to help me with some of this. So please extract, so Limini bootloader is this bootloader that's pretty popular, and I'm using it for this OS, and that's where a lot of these bootloader people live. So you might get some advice from them there. And a pure virtual interface for this class a bit above in this file called ibitmapFrameAllocator. And so I have this class, I want to extract an interface for it. So that looks pretty good. I wonder though. So then it did this. I think that looks sort of okay. I'm just gonna ask it, do we need a virtual detour? I think we do, right? You usually want to have the virtual destructor. So, oh wait, it already has one. All right, right. Misread it. Okay, so we got the actually, it's a good point. It didn't need to be named bitmap frame allocator. iframe allocator is good enough. So I'm sort of okay, quick check on, is my git clean? It is. So just to continue to kind of sketch this out. So here we're gonna take an iframe allocator for starters, because if we go back over to our unit test, how are we even doing this now? I mean, does the unit test compiles and runs, right? Yeah, it runs. Code with Shiraj. How as good as you? I mean, dude, I've been programming for so long. I've been programming for like 10 years, like 13 years, I don't know, something like that. So, and I've just been learning like all the time, constantly for like that entire time. And also working jobs that made me a lot better at programming. So yeah, okay, so here, this is kind of interesting. We all right, what about this? So iframe allocator. What if we did this? We're gonna do struct mock frame allocator, click iframe allocator. Just do fill in blank skeleton. And we're just gonna need to implement that API potentially. Where do I get? Oh, I actually did like a lot of the work. We'll code review that in a second. Where do I get started? Yeah, I mean, yeah, basically there's this MIT course. So I don't know why my chatbot's not working today. So personally, this is what I did. I just did that course. There's maybe better ones, like Harvard has one. I think I've been recommending that to people. I mean, the starting point is week 13. And so if you go, I mean, you can kind of clear, I tried to make it a little bit clearer what is laid out. So era 0 is kind of garbage. You don't need to watch that. Era 1 is sort of where I actually start doing this. And I started just doing that course, and it was very helpful for me. Okay, and so what did it do? This is very weird and kind of wrong. Okay, what I want it to do is, well, I'm just going to delete. I think, yeah, I didn't. It's like kind of weird. I also don't really know anything that the num-free frames is going to have that there. Basically what I'm envisioning here is like calling malloc. It feels very odd to do this. Return. Now here's the intro. I need to return a VirtAddr type. The VirtAddr is basically UN64T. So something like this. Although, yeah, I'm gonna drop this change. Keep this. Okay, first question, does the UT thing automatically run it? Oh, unit, wait. Make host, right? That make host. So this does compile. Like if I just, this should not compile, right? This fails to compile. Cool. So I'm weirdly calling malloc. Maybe there's a better C++ way to do that. Yeah, oh, sick. Turned on notifications to catch you live, so like ask questions, totally worth it. I'm glad to hear it. No, I'm happy to hang out and chat. talk about computers. That's my favorite thing to do. Appreciate that, Prita. Prita or Pritam? Yeah. If p return null opt, something like this. What am I doing? Return p std null opt. Okay. Something like, oh, but now. Ooh, this is gonna be yucky. That's the problem with using the ternary. There we go. So now we just do that. This is all a huge experiment, by the way. I don't know if this is gonna work. Now I need to wait, what am I doing? I'm not returning. I'm calling. Is it stood free? I literally don't know. Can you do that in C++? This is so strange to be calling malloc and free, but I literally just want a raw buffer of like 4K, and this is the most straightforward way I could think of to do that. It's VAddr, yeah. And this is, so I need to first cast this to, it's kind of strange. So is it not possible? What? Wait, what's up? Wait. Quick, man free. It takes a void star, right? Why can't I cast to void star here? Reinterpret cast. Holy crap. Do I really need to reinterpret cast? No, wait, what? It's, oh wait, no, that has to be a stale error. No, cannot. Wait, what? Okay, one more time. UN64. See, this should totally work. No, cannot cast. Cannot cast. Why not? Maybe I'll ask over here. Why can't I cast from U into 64T2 void star? Int pointer T. Interesting suggestion. Maybe. Pointers in. Okay, I'm going full on with the reinterpret cast. So that's kind of the idea, I guess. And I mean, this thing, we're just sort of not implementing it. So assert I don't know. Does this compile? this is all a huge experiment. I don't know if this is going to work, but I'm trying to basically now that we have that, we will be able to I don't know. I mean, yeah, we'll mock. So just like do this, I guess. The problem is, what about this thing though? I didn't fully, I was just guessing when I was making the design for VAddressSpace HPP, and I required passing in a pointer to the PML4 table, which is this thing, which there's like one instance of. And I don't know about that. I don't know about that decision. Maybe, well, for one thing, it's causing problems right now. I mean, one thing I can just do is I can just literally do this. Require, and I oops, VirtAddr but then I'm going to run into this problem again of not being able to convert. Interesting that it is okay to cast from a void star into a UN64T, but not the other way around. Anyway, so why is there a squiggly line here? I cannot even read that comment. No instance of constructor. What problem? Oh, wait, what? Oh, have I been doing this in the wrong? Oh shit, I've been doing this in the wrong file. There are, for some reason, there's weirdly two of these files with the same name, because I am in the middle of sort of figuring this out. So, okay, so let's try that one more time. So Prita, not caught up with the required knowledge yet, but would love to join when you do. The schedule, I stream, okay, so usually I stream every week on Sundays, and that's my usual schedule. It's every Sunday at 10 a.m. Eastern time, like Eastern of the US time. That might change though, so the best way to stay updated is to join the Discord, which Discord? I always post updates in the Discord if there are any changes to the schedule. By default, it's Sundays at 10 a.m. Eastern time, but that might change in the next couple of weeks also. So, for example, like right now, it's not Sunday. So, what's up, experiment? Okay. Speaking of experiments, let's keep going with this experiment. So now, what? Oh, dang. Okay, so wait, yeah, so now over here, we need to not do this. We need to hold an iframe allocator. Is it possible to write an own garbage collector for C++? Garbage collector for C++? That's an interesting question. I mean, sort of the whole point of C++ is that you don't use a garbage collector. So I don't really know, to be honest. Okay. This is building now. And so we are theoretically able, we are able to create the VAddressSpace and pass in our mock allocator, basically. I'll call it the mock allo. Or maybe not, I don't know. Maybe not, discard. And now it's time for the converter. Basically the same thing needs to happen. Please extract an pure virtual interface for this class. Why you're not writing x86 assembly? Well, nothing I'm doing right now requires writing assembly. So, and I'd like to avoid writing assembly if I can, kind of. So I guess that's why. A friend said, if you can make an OS, that means you understand when you kill the palm tree. You understand how a computer works inside and out. Do I agree with this? I agree that if you actually do it, it forces you to understand a lot of parts to a computer, but computers are so complicated. Like, they're so complicated, and there's a lot of parts of a computer that are the internal implementation details of the computer and are not exposed to you even as an OS developer. Things like the internal implementation of the instruction set, stuff like this. And so even if you're a master OS developer, you don't necessarily know those details. But I would agree that if you are actually able to write like a really production OS, you definitely have strong understanding of how a computer works. So now this is interesting because it did a bunch of changes. So it extracted the interface, which is kind of nice. It also renamed a few things, which I did not necessarily intend. I'm gonna reject those. I also added some consts here, which are useful, but I'll just keep them in. Okay, so now we have our VAddressSpace converter. And I'm going to attempt a similar thing to what I did over here. So we're no longer taking the FizzMap_adder converter, we're taking the VAddressSpace converter. And similarly, we are taking the VAddressSpace converter. And in doing so, we've made VirtAddr sort of abstracted from the hardware. Now it's no longer directly calling into the bitmap frame allocator or the FizzMap_adder converter. It's calling into these abstract interfaces, iframe allocator and VAddressSpace converter, which can basically choose different implementations depending on whether we're running in the kernel or in the unit tests. The 20-second pop-up is called timeout, this Mac app. And I'm a pretty big fan of it. Okay, so now the idea, again, we're going to try to mock adder converter. Right. And oops, dang, what the? Const override or dang. Okay. Add no op impulse, just return the same value back with casts. I'm trying out my AI assisted development workflow here. So basically for the mock adder converter, we're not doing anything really. Physical and virtual just means the exact same here. And so we're just like going to cast it back and return the same value basically. What's up, Varagul? How do you handle mounting drivers? So so insmod driver name. So that's loading a kernel module, and my OS is so far from kernel modules it's not even funny. So I don't have that right now. And yes, I've definitely heard of Temple OS. Yeah, it's a cool project. Okay, so now check it out, mock adder converter. And this is sort of like the moment of truth. So now we've instantiated the address space and mocked out these two dependencies of the frame allocator and the mock adder converter. And like theoretically, we can just start to actually test VAddr. And now theoretically, we can start to try to implement this. How long will it take to write an OS? Probably the rest of my life and more. I only develop for 2 hours a week, which is not enough time to write an operating system by myself, surely. So it might take me a few lifetimes. Rest of my life. Yeah. Let me just quickly see. So it's 6:23. So I'll go for another 7 minutes. I'll get to that Pritam. I just want to try to do one last final thing here, for example. Okay, also what, so in the VirtAddr thing, we probably, it would be good to expose a method for returning the raw adder. We probably want that. Okay. So, okay. So for example, I was just like, validate alignment. So we probably want to validate alignment. So we, like, for example, is aligned dest VAddr, right? That's probably something we care about. Is aligned is over here, right? So maybe zooming out. Mapping. So what is mapping even? We're trying to, we have this idea of an address space, and by default the address space is empty. There's nothing in the address space, and that's known as, another way to say that is nothing is mapped into the address space. It's an empty address space. There's nothing living in the virtual address space. And if you try to do memory accesses into this address space, if nothing is mapped, you will fault, page fault. And so we're trying to put things into the address space, and that action is called mapping something. We're trying to map something into the address space such that you can do memory accesses against that region and have it not page fault. And this is what we're looking at here. So map the API. The idea is that you can pass in your destination virtual address where you want the thing to get mapped to, and it will map this frame of memory basically at this dest VAddr. And yeah, to do so requires me taking the page tables. And so just as an example, as maybe the last thing we do today, let's just try to use these interfaces that we extracted. So like, I don't know, what would that look like? And so in our weird API, we are requiring the caller to pass in a PML4 table, which is this thing, right? And so, I mean, actually, another thing, we're missing a lot of other supporting infrastructure. We're going to need structs and classes that model the page table entries and all sorts of things here. I don't have any of those right now. But let's ignore that for one moment. So the first thing we're going to do for index is we're going to go get, and we're going to use that API we implemented earlier in the stream. So interesting. And here's the part where I need to mark this as const. Okay. We're going to use that API from earlier in the stream to extract out the PML4 index of this address. And then we're going to use that to index into the PML4 table. And here's the part where I don't have any abstractions for managing things. And so I need to index into this PML4 table, but I currently just have a VirtAddr pointer to it, which is super weird. But for starters, I'm going to use the mconverter and call phys to virt and pass in the mpml4 table, which gives me a virtual address which I can work with. Which is a void star. And then I'm just going to quickly sketch this out. Page table. I'm going to call it the generic page table. And it's going to be, oh, maybe this is an opportunity to use stood array. I'll be so excited to do that. Stood array, and it's what, a 64 64-bit, and there are 512 of them, something like this. Entries. Is that right? 8 times 512 is 10,496. All right, something like this. We got our generic page table, and this is not totally right. Like, this should ideally be not just a uint64, but like some kind of type, like a struct PML4 entry or something weird like this. Please fill this in with bit fields. I'm just curious if the AI can do that for me. That would be so cool. I want a structure that matches the struct layout of a PML4 entry. And I don't know if that's right, but I'm gonna go with it. So basically, for entry and the type name, it's he. And so, all right, I lied, I'm gonna go a bit past. I'm using GitHub Copilot, which I understand to be a little bit similar to Cursor. Okay, so now here's the idea. Generic page table. And so now here we get the, and so now it's something like generic page table, PML4 entry, I'll just call it P. It's a bad name. And it's literally just this. So we're crafting a pointer. Wait, a pointer. Does this need a cast? I think this needs a reinterpret cast. Dang. I'm pretty sure we need a reinterpret cast here. Yeah. Okay. So we're casting this sort of void star into a very specific type here, the generic page table for the PML4 entry. And lastly, as the last thing I'll just do, what we're going to do is index into it using the PML4 index entry. And this is going to give us a PML4 entry. No, it's going, I see it. So I need, that is giving us a type generic page. No, I want like an at, or something like this. Trees, something like this. So now we're gonna get the P table. This is all a total experiment. I don't really know what I'm doing, but okay. Now we're indexing into the PML4 table at a specific offset, right? That's the goal here. We retrieve the offset from this section of the virtual address. We grab the table, and then we index into a certain offset into the table, and then this thing is going to be a reference to the PML4 entry. And that's where that's where we can do stuff like entry.present or whatever. Like if entry need to map a PDBT table or whatever, and point to it. And I will leave this stuff for a future stream. Okay, does this code compile? always a question. Code does compile, but that's probably because it's not like being even used. If I add a syntax error, I think it, actually no, it does compile. Because it's being linked into kernel lib, right? So we have not used, okay, we have not used the allocator yet, but let's do it. So now what we're gonna do here is we're going to use the allo. We're gonna get a new frame, and that's sort of it. I'm just gonna log it. Got frame. What's the OS able to do? So I really want to set expectations clearly. My OS is in such an early state. I mean, let's just check out the kmain. My OS does not do anything. My OS Q. Apparently I forgot how to run my OS. Chemo? What? Holy crap. So I don't know what happened there, but my OS does not do anything these days. Like it boots up, it receives control from Limine, it logs some stuff out, it can parse some arguments if you give it arguments, it dumps the memory map, and then it just enters a bunch of like random play code that I'm working on now. So it does not do anything basically. It's such an early little tiny OS, and apparently I forgot like why. Cross compiling. Holy crap. Whoa, why? Okay, no, that looks right. Catch 2 with, wait, what? Wait, whoa. Something is so wrong here. Why is my, what? Host? Target host, right? Presets. What happened here? Okay, man, I'll need to debug that. I have no clue why running the target build is running the host. It's running the unit test build. So anyway, let me sort of finish up the thought I was working on. So VAddressSpace over here. So I was just going to log frame. It's gonna freeing, and I'm just going to and what it takes a physical address, right? So I need to frame. And then I'll probably just like assert. I just want to see this run. I just want to like run this in the unit test. Can I call calloc here actually? I want to calloc. I want to, dang. Yeah. So I'm trying to zero out the memory. And I want to just run one test. This thing to check false. What I want to do, I want to just do a simple call of map. So I'm just going to choose a random, I'm going to map it at 8. I'm going to map it at 100,000 hex. And I'm going to map, just to make it a little less confusing, I'm going to map physical address 1,000 into virtual address 100,000. I'm going to try to do this. It's going to hit this code, and we'll see what happens. And if I'm hoping to see this text, and I'm going to print a few other things out. I'm going to print out for table. For table. Because I also want to confirm on this side that it's the same as this malloc address. So I'm going to just come over here. And I'm just going to print out the P. Like basically what I would just want to do is confirm that all of these mock things I made are working. And I'm gonna just try that. Malloc assertion failed 773. Okay, perfect. Here we go, check it out. Let's go. So Malloc's PML4 table at 1348. That's coming from over here. And then over here, well, no, Malloc's, wait a second. Wait, I'm confused actually. Let me focus on malloc PML4 table 133. Then this thing says PML4 table 133. So these are the same addresses, and so that's a good sign. So the address we see over here, after we run it through like the null conversion, is the exact same thing that was passed in. My question is, why do we see this text twice? That's a little bit strange to me, but anyway. All right, anyway, we got this PML4 table. So now we're allocating a frame, and so this is another malloc kind of thing. And 134. Oh, this is interesting. Anyway, we get a frame and we free the frame. And what I kind of want to do is debug this, I guess. It would be really cool to step through. I don't know if I can exactly, I don't really know how I would do that. Let me just quickly try it. Actually, yeah, no, straight up, how do I do this? Yeah, okay. Usually I do this in a VS Code extension, which I don't have installed, so I'm not as familiar, but let me see. Let me just try to break on the map. So I want to break on the address. Oh, okay. Or maybe can I copy file name? Copy name. I want to break on line 56. Now I'm going to continue. Dang, I'm gonna break main. Going to run. We're in main. I'm going to continue. Check it out. Okay, now we're broken on this line. So now we can just kind of step through. So what we're seeing here right now is I'm debugging my unit test. This is not the real kernel. This is the unit test. And so the kernel, parts of the kernel are compiled into a unit test that runs on my Mac. That is what we're debugging right now. And we can just see, we're just stepping through this code running on my Mac. And for example, PML4 table. So this, M, yeah, maybe PX 14D, right? Let's just keep going. PML4 table, blah, blah, blah. That is the exact same thing we just saw here with the two A's, right? And so converted that quote unquote physical address, which is just a virtual address, back into a virtual address. Here we are getting the entry and everything should be 0 because we zeroed out the PML4 table. So there's no bit. And then here's what I want to step into. Here we're going into the mallo.alloc. And I'm gonna step and check it out. I mean, this is how I expected it to work, but we're hitting malloc, literally like user space malloc running on my Mac. And this is the mock layer behind the VAddressSpace. And so we're literally just calling malloc right now. We get the malloc, we print some stuff out. Now we're trying to, just as a playing around, we're just going to free it, step inside, and we call user space like libc free with that address. And that is that. And so it seems like things are kind of working. So our basic setup where we have a virtual address space class that has been abstracted from the hardware and can be run in a mocked unit test environment sort of seems to be working. And maybe there will be some crazy problems in the future from doing it this way. But I have a bit more confidence now that it might work. So, okay, that was cool. I'm going to slowly bring the stream to an end, but I'm going to answer some questions before I do. So let me come back over here. So thank you for all the questions, everyone. Thank you, Pritam, for the questions. Okay, so Can you take some time out and tell us what stage you're in currently? So I'm in extremely early stages of the OS. What I have so far is I have a good project infrastructure. I have the cross compiler, I have the compiler set up, I have the debugging set up. Kimu was running, but I don't know what happened to it today. I have a build system with CMake. I have a bunch of third-party libraries. I'm using C++23. I have partial standard library support available for things that don't require memory allocation, thanks to some of those third-party projects like freestanding C and freestanding CXX headers. I'm using the Frig library also. So I have just all this stuff rigged up and prepared in my build system. I'm using the Limini bootloader with the Limini boot protocol. And so that means I need to be on a 64-bit, that means my OS needs to be for 64-bit, and so I'm doing 64-bit x86. And with all of that foundation now under me, I'm actually kind of starting my kernel now. And the first goal is to move away from the bootloader page tables and move towards some page tables that are created for the OS. So the OS is kind of production page tables. Because the page tables you receive from the bootloader are not exactly meant to be used for like the lifetime of the operating system. They're mostly meant to be just a transition mechanism to allow the OS to take control and then redo everything like it wants to do. So that is the general idea right now. Working on getting the kernel's page tables and virtual memory set up. As far as the K main goes, yeah, we already kind of looked at it, but it just reaches the end of the kernel. Like, it doesn't really do very much right now. So we're in super early stages, but we have a pretty solid setup using a modern language with some modern features. And so that's sort of where we are at with that. How do I find this again? Every stream, I just try to make a little bit of progress every stream. That's pretty much it. I don't have a plan. It's kind of hard to predict how this will go. So yeah. Okay. Sorry, going back here. Have you completed writing a bootloader? I have not written a bootloader. I think that's a major misconception. You do not need to write a bootloader when you're writing an operating system. You can use other people's bootloaders, and there's a lot of good reasons to not write your own bootloader. Number one, like, writing your own bootloader is like really hard. Even harder than it's just more. It requires interfacing with very specific kind of arcane details, and compared to the whole journey of writing the OS, in my opinion, writing the bootloader is a little bit of the less interesting part. And so you can use Grub. You can also use Limini, which everyone is doing in the hobby OS scene these days. Also, bootloaders give you a lot of nice services like command line arguments, like a boot menu, memory map, and like all these other services. And so it would be a lot of work to re-implement that one, and that's just work that stands in your way of getting to the actual interesting part of writing the operating system. By a PC? I mean, that's a very broad question. Depends on your budget, depends on like Windows, Linux, Mac. I like Macs. If you can afford a Mac, I've really enjoyed my Mac computer. I've had them for a long time, so. Okay, Mac M4. Those are incredibly powerful machines. Those are more than enough. You do not need a powerful computer to do OS development. You really don't. You need to be able to run a compiler, and you need to be able to run an emulator and a text editor, basically. Did I implement segmentation part? So I'm in 64-bit mode, which means segmentation is disabled, and so There's nothing really I need to do there. Can I paste the repo link? There is no repository. I've not made this public because I just don't want to right now. And so there's no public repository. What's up? I make video games. Hello. I've been programming for like between 10 and 15 years at this point, depending on when you kind of first count it. I've been working professionally as a programmer since 2016 or so. How do you even know what to do? So I took this MIT course. That was like the first like 60 streams of mine were like doing this MIT OS course. And that's how I learned the basics of like how to do an operating system. And from that, and also a bit of talking with some peers and stuff, I just have a couple of steps ahead of me. I don't know the whole plan. All I know is that right now I need to get virtual memory working for my OS. And I have a good enough understanding of what I need to do to make that work. So I'm just working on that. Trying to make best game. Bro, I've been programming for so freaking long, man. I've been obsessed with this for like over a decade, and so don't worry about that. Thank you. Love watching the code. Appreciate that, Ruben. No, there's no name for the operating system. It's unnamed. How old are you? What's your occupation or experience? I'm in my early 30s. I work in the music tech industry on a hardware product for making music. And yeah, before this, I was working in the cybersecurity industry. All right. This has been a lot of fun, everyone. I really appreciate everyone tuning in. This has been a great stream. 27 people in the chat. That's like way more than I've been getting in a long time. I'm going to end the stream now, but I'm going to post my Discord link. Feel free to join the Discord. I also have an ask. If you are interested in like what I'm doing, I would like to ask you to subscribe to my YouTube channel first off, but I also have a mailing list, and I'll be posting updates to my mailing list also as this project goes on. And I'm also thinking of adding opportunities for if you want to like coach with me, or maybe do mock interviews or like stuff like that. And so if you want to stay updated and just kind of stay connected, I would really appreciate if you joined my mailing list. That would be very meaningful, because also I've been kind of getting nervous about online platforms. Like my Twitter account recently has been like shadow banned or something. Like I have like my tweets, like I make a tweet and like no one sees it anymore. And so I'm kind of concerned about that. So a mailing list helps me stay in touch with you a lot better than like even Discord maybe. So if you don't mind, I would appreciate that a lot. And I think that's pretty much it. And so like I was saying, I stream, it's usually Sundays, 10 a.m. Eastern time streams, but updates are in the Discord, because I might change that. And so make rage bait tweets and you're good to go. Thank you, Embray. Appreciate that a lot. Yeah, so I'll be back sometime next weekend probably, and we'll keep it going. I mean, we made a lot of exciting progress today, and we'll get to some more exciting stuff with the virtual memory. And I think you are all really start like joining at a very exciting part in my project, because I'm about to work on some of the really core essential pieces of the operating system, like virtual memory and stuff like this. And so we're kind of really just getting to the good part like right now. So, okay, what MacBook? I have like a MacBook Pro. It's a pretty powerful one, but I plan to have it for 10 years. So yeah. And how do I proceed? Okay, last thing, my resources page. I would like to make something better for you all eventually, but for the moment I have like a resources page. And I would probably start with some resources there. I recommend pwn.college to everyone. It's like a website. That's a bit more security related. These are all great places. Okay, that's a wrap for today. Thank you so much for joining. Have a great week, and I'll see you next week. All right, peace out, everyone.